Okay, we're going to talk about literal equations. A literal equation is an equation that contains two or more variables. Our first example of a literal equation is A equals pi times r squared. This is the formula that we use to find the area of a circle. Because it has two or more variables, then it's called a literal equation. So we're going to take this equation and we're going to solve for pi. Now, solving for pi is just like solving our equations. So our goal here is to get the pi isolated. When I look at this equation, the only operations that we have in this equation is multiplication. So in order to solve for a variable or an indicated term, we're going to use inverse operations. So if all we have is multiplication, then the opposite of multiplication is division. So look at your equation. We're going to focus on the side of the equation that contains pi. Right now, pi is being multiplied by r squared. So if I'm going to isolate it, I have to undo that operation, and the inverse of multiplying is dividing. So I'm going to divide both sides by r squared. These cancel, and I have a divided by r squared is equal to pi. So your pi is isolated, and you're going to have a divided by r squared will give you the value of pi. Okay, for our second equation here, we're going to use v equals 1/3 s squared h, and we're going to solve for h. Okay, so here's a rule. Anytime you have a fraction, let your goal be to get rid of your fraction first. To get rid of a fraction, you multiply both sides of the equation by your denominator. So my denominator here is 3. I'm going to multiply 3 times v, and I'm going to multiply 3 times the 1/3 s squared h. 3 times v is 3v. Here, these 3's cancel, and it leaves me with s squared and h. We're solving for h, so we're going to focus on this side of the equation because here's your h. The h is being multiplied by s squared. So to undo that, we're going to divide by s squared. Dividing both sides by s squared, you're going to get 3v over s squared is equal to h. Alright, so your h is isolated. Okay, so now let's look at P equals 2L plus 2W, and we're going to solve for W. Now this formula should look familiar because it's the formula that we use to find the perimeter of a rectangle. We're going to solve for W, so we need to focus on this side of the equation. In this equation, we have some addition and multiplication. So the inverse of addition is subtraction. The inverse of multiplication is division. So we got to do some subtracting and dividing. We always subtract first. So we're going to subtract 2L from both sides to isolate the term that contains the W. So P minus 2L equals 2W. Now I have the 2 and the W being multiplied. The inverse of that is division. I'm going to divide both sides by 2. So I have P minus 2L over 2 equals W. Now if you want to split it up, you can. And it could be P divided by 2 minus 2L divided by 2 equals W. If we split it up, then we need to simplify because here these 2's can cancel, and so we have P divided by 2 minus L equals W. Okay, these two are equivalent, so either answer is acceptable. This is pretty basic. All right, your fourth example is AX plus B equals CX plus D. And here we're going to solve for D. So, first thing we're going to do is locate the D. Here's the D. On the same side as the D is CX. This is addition, so we need to subtract CX from both sides. So I'm going to have AX plus B minus CX equals D. Now, you may consider these to be like terms because they have one variable that's the same, but we can't combine the coefficients. Your D is isolated, so this will be your simplified answer. Okay, for number 5, I have I equals P times 1 plus RT, and here we're going to solve for R. Alright, so we have a P here that's outside of the parentheses. We can look at that two different ways. We can look at it as being P times the terms that are in the parentheses, or some of you may want to go ahead and distribute. Well, since we're solving for R, and R is trapped inside of the parentheses, then I'm going to go ahead and divide both sides by P first. These P's cancel. Then we have I divided by P equals 1 plus RT. Okay? And so now we're going to subtract 1 from both sides. And I'm going to have I divided by P minus 1 equals RT. Okay? So now to get the R isolated, I'm going to divide both sides by T, or I'm going to say multiply by 1 over T. Here, the T's cancel, and I have 1 over T times I over P minus 1 equals R. And now we can distribute, and we have I over TP minus 1 over T equals R. And this one is a little bit more complicated. This will be more of a challenge type problem. So you have 5 examples of literal equations, and the only difference between a literal equation and a regular equation is we have more variables and fewer numbers. But we still work our order of operations from the bottom up. We always start with either addition and subtraction, and then we move to our multiplication and division.